Now I would like to ask to the podium Andreas Sofianopoulos. Andreas Sofianopoulos is Alexandros, but excuse me, sorry.
Beautiful name, by the way.
Yes. Alexandros Sofianopoulos is the Chief Operating Officer of GEPGroup, responsible for the seamless development and delivery of health and safety consultancy services, envisioning a robust health and safety culture in the workplace. Alexandros holds a master's degree in mechanical engineering and over the past 20 years has served as health and safety director for a variety of organizations spanning a wide range of sectors including construction, manufacturing, industry, renewable energy and oil and gas in Greece and abroad. Alexandros actively participates in various conferences as a considerable member and a distinguished keynote speaker. Thank you.
Thank you very much, sir. Good afternoon, ladies and gentlemen. Thank you very much for the invitation to be here in this wonderful conference. I attended all the presentations with a lot of attention, and I noticed that everything was about the safety and the wellness of building users, the occupants. Now, what we are going to discuss about is the safety and well-being of the actors at the backstage, the actors that are actually performing the retrofitting projects. So, having said that, retrofitting projects, energy retrofitting projects, are not only the upgrading systems projects, but also adding insulation materials to walls, roof, floors, installing energy efficient windows and doors, implementing renewable energy sources, just like solar panels, and so on and so forth. The benefits, of course, the obvious ones, are reduction of operational costs, the compliance with environmental standards, and also the overall enhancement of building environment. Why is safety so critical for all the actors that actually delivering the energy efficiency retrofitting projects? Because workers are exposed to construction-like environments in existing buildings, sometimes with occupants present. Avoiding injuries improves productivity and maintains project timelines. Safety also contributes to long-term cost saving by reducing the related cost of injuries. Definitely, it is also linked to regulatory compliance and reputation management of the company. And what are the key safety challenges in retrofitting projects? Working in occupied buildings where retrofitting must be non-disruptive. Working at heights in outdoor areas. Sorry, let me just fix that. Exposed at extreme weather conditions. Older infrastructures may hidden some risks, just like weak structures, asbestos, and outdated wiring. Working in confined spaces, just like attics and crawl spaces. And finally, lifting and managing installation of heavy machinery and equipment in all the existing structure. What is the basic tool that we use in order to proactively set up the respective safety programs in place? It's called risk assessment. It is based on standard methodologies, following the next steps that I'm going to describe you shortly. First of all, we identify the hazards or that are specific to the jobs that are going to be performed. Then we evaluate the respective risks out of the standards, usually using two parameters. One is the likelihood, and the second is the impact. The likelihood of occurrence of an incident, and also the impact of this incident that may have, not only on persons, but also on equipment, and also the environment. Then we select the proper control measures to mitigate those risks, either engineering controls or administrative controls, and we monitor their implementation on the field. Finally, and as long as the projects move on, we review and update the risk assessment document, since it is a living document and not something that stays stable, let's say, since the initiation of the project. The main risks that we may encounter, main hazards that we may encounter during energy efficiency retrofitting projects are falls, electrocution risks, chemical and toxic exposures, confined space, struck by incidents, use of cranes and use of forklifts, CMOPs, which is actually the abbreviation for simultaneous operations, and finally slip, slips and falls. Risk of falls can come from the use of portable scaffolds and ladders that workers are called to use, especially when they have to get access, let's say, to higher points, that if they are not properly installed and maintained, we may increase the risk of falls. Definitely we have rooftop access that we don't have all the time safe access point to reach the rooftop. We have all roofing materials in conjunction with floor openings, meaning that the existing structure may not be designed to accept all this new equipment and heavy machinery and may be prone to collapse. And also we may have openings just like balconies, roofs, and so on and so forth that are not protected with guard plates. And so risk of falls increase again. In some cases, because we have difficult spaces in existing buildings, workers are called to improvise and use makeshift work platforms or even aerial lifts, and this also increases the risk of falling. Absence of guard plates is something that we already mentioned, and also we would like to mention that there are cases where no anchorage point exists on buildings, so the workers cannot attach their safety harness over there in order to protect themselves from falls. Crowded and restricted workspaces, especially when we have a lot of materials to be stacked near the edges of roofs, where risk of fall is increased. And finally, we have the weather and environmental conditions, meaning that slippery surfaces can be created out of rainy conditions, snow, or ice, as long as poor lighting, if we don't have the proper lighting conditions, can also increase the risk of fall. So what do we do? Before the project starts, we implement engineering studies in order to identify the proper engineering controls, such as harnesses, guardrails, and nets. Then we invite the proper licensed and certified personnel to install and inspect those systems before the work starts. It is really important to have all the workforce trained to deliver an accredited and certified training at works at height, and finally to make sure that all workforce are medical fit to perform safely work at heights. Now, from the left-hand side to the right-hand side, we can see the most effective to the least effective means of protection as far as it concerns from height. So the first one is, of course, to eliminate a hazard, instead of working at height, just to do the same job from the ground, from zero level. Then we move to passive fall protection systems, and fall arrest systems, and finally to the least efficient administrative control, which is the use of signals and also procedures to follow in order to avoid falls from heights. Some real-life cases. On the top you can see two types of flexible safety lines that are installed on different types of roofs, whereas at the bottom you can see some types of portable anchorage points that are also installed at the rooftops. Electrical risks. I think it's very well straightforward that workers during energy retrofitting projects, they are facing a lot of different risks, just like exposed wires, live panels and switch gear, overload circuits and equipment when we are using a lot of different portable equipment, and let alone that we can have arc flashes and electrical explosions, not only from faulty connections, but also from switching operation, especially if not the proper protocols to isolate the electrical power on the panel are not followed. Compatibility of new systems with old infrastructure is also a big issue, and if it is to consider that we have renewable energy sources, just like solar panels, where inverters and transformers of high voltage are used, then it is expected that we may have some overheating and definitely some electrocutions. Faulty or inadequate grounding, it's a disease of most older buildings, I would say, that they are not equipped with proper grounding connections and also floating neutrals that can provoke unexpected currents that can harm the employees that are working on energy retrofitting projects. Finally, we have environmental conditions such as moisture and water egress in conjunction with dust and debris that can create some capacitance over the panels and the rest of the electrical connections and may cause short circuits and respective risks. So what do? Again, we put in place the risk assessment and the proper mitigation plan using engineering documents just like the single line diagrams of the current installation. We make sure that all the equipment that we use is well maintained and certified for the job to get done. We make sure also that all the personnel that are involved in electrical tasks, they bear the proper license in case needed, and definitely they have the proper training to be aware of the related safety risks. We put in place safe work procedures like lockout, checkout, testing methods, use of PPE, and also we define roles and possibilities according to international standards for instance 50, 110, according to the level of authority to intervene in electrical panels and installations. We put in place emergency protocols in order to be able to respond to any emergency, and also we use the proper PPEs. PPE stands for personal protective equipment, according to the attributes of the respective electrical installation that are going to intervene. Some indicative examples of the lockout/tagout equipment includes the HASPs, which actually the tags, which actually are the labels that we put on every installation to inform that some intervention is going on. The HASPs and also the logs. For each and every task that is being done under the conditions of lockout/tagout, each and every worker should have their own lockout/tagout in order to make sure that no re-energization of the equipment will be take place until the time that all the works have been completed. Chemicals. We talked about a lot of different agents, I think, in the past. Now it is time, let's say, to discuss about the chemicals that are brought on site before the projects start. So we have a lot of adhesive, paints, sealants, and finishes that include volatile organic compounds. We have lead and asbestos, especially in older buildings where they were used as insulating materials. We have cleaning agents and sealants. And we have refrigerants, either hydrofluorocarbons or natural refrigerants, just like ammonia or carbon dioxide. Each and every of these chemical agents can have a different health impact to workers, starting from simple irritation of the respiratory system, maybe moving to chronic diseases, lung diseases, silicosis, and even worse, cancer. Silicosis can be created from long-term exposure to silica that is being created when we are drilling concrete and also bricks, whereas the rest of the dust that can be formed from the construction and demolition dust and also fiberglass and insulation materials can irritate significantly the respiratory system of the workers. What do we do again? In the beginning, we perform a dedicated risk assessment using specific information coming from material safety data sets for each and every chemical. We use all this information to train the employees on how to avoid those risks and also to use the personal protective equipment that they have at their disposal. It is really important to regularly monitor and perform permanent air quality testing, especially when we know or we suspect that we have the presence of asbestos at the related works. Finally, it is really important to put in place emergency response procedures to be able to respond to emergencies. Typical engineering controls that we put in place is ventilation to be able to suspend, to absorb the contaminants, the dust at their source. Then we move to isolation and containment. We put barriers and also negative pressure systems to avoid the spread of the cloud, and wet methods, especially when we have activities just like drilling or use, let's say, grinders on concrete materials. Finally, we have the use of PPEs. We select the most proper PPEs according to the nature of the contaminant and also the concentration that we can measure from the respective measurements. Confined spaces. Confined spaces are very sensitive spaces, and I will tell you exactly why. First of all, we need to define what a confined space is. It's an area that is large enough for a worker to perform tasks, has a limited or restricted point, means of entry or exit, and it is not designed for continuous presence of the employee. Some examples in retrofitting energy projects includes, but this is not exhaustive of course, boiler rooms, HVAC ducts, crawl spaces, utility vaults, and also storage tanks. So when it is to identify the hazards inside the confined spaces, we need to consider that the hazards are not only the inherent ones from the configuration of the confined space itself and the equipment and the materials that is kept inside, but also we have to consider the risks that are integrated, introduced to the confined space from the materials, the chemicals, and also the equipment and the nature of the task that we are going to perform inside the confined space. So actually it's a combination of two different things that we should consider prior implementing the proper mitigation measures. So the list of hazards are divided into two categories. First of all, we have the atmospheric hazards. meaning the oxygen deficiency, toxic gassing, and flammable vapors that can be present inside the confined space area. And we have the physical hazards that we're talking about. The limited egress can be really, really dangerous, especially in case of emergency. We have the engulfment in case of storage of granular material or even sand, and the electrical hazards from all the equipment that is inside the confined space itself. A robust program to face to mitigate the risks related to confined space starts from proper ventilation, ensure ventilation to dilute the harmful gases and also to maintain the oxygen levels at the proper level. Gas monitoring, it is really important to continuously monitor gases in order to identify any toxic concentration, flammable concentration, or even to make sure that the level of oxygens are adequate. Safe work procedures, meaning implementation of safety protocols to ensure safe entry, working, and exit from the confined space. Really important to train all the employees that are involved in this specific task, and emergency protocols to provide all the necessary training, specialized equipment, and how to use it in case of emergency inside the confined space. As far as it concerns, track by risk can be present everywhere at the construction site, as we very well understand. So let's go through quickly, let's say, the main categories of such type of risks. Falling tools and materials. Every worker has the tools on their belt, and something may fall, let's say, from a height. We have loose building materials, especially when we start demolition, and mechanical equipment when we're using forklifts or even cranes. Something may fall, let's say, from height. We have a lot of moving vehicles, just like forklifts, as I mentioned, cranes and delivery trucks, that especially if we have mixed circulation between vehicles and also pedestrians, and we don't have a regulation of traffic, then we may have collisions, or we may have risk of workers being struck by those equipment. Power tools and equipment. We have nail guns and fasteners, we have cutting tools that can create ejected particles and can injure the surrounding workers. Flying debris from demolition work. As we mentioned previously, for energy retrofitting process, it is common, let's say, understanding that we may have some partial demolition of walls, bricks, that if not properly secured, then they may collapse and they create the respective risk of struck by. From partial demolition, we have also the risk of dust and particles that can create the same risk. Structural instability, meaning that we may have collapsing parts of the existing structure, especially when we start doing all the retrofitting activities, and we may have vibration for power tools that are used to complete the respective tasks that can create some instability on the existing structure with related risks. Finally, we may have some interventions on networks, just like compressed gas, and also FAC systems, that if not properly isolated, as we discussed earlier, or make sure that all the energy sources are deactivated from them, we may have ruptures that can create some ejected particles risks. What are the engineering controls that we put in place? We use tool tethering and also securing materials, guardrails and two bars, barriers and exclusion zones as far as it concerns the setup of the cranes, and also the circulation of the forklifts. The administrative controls that are deemed as appropriate for such instances are pre-task planning and risk assessment, as we said, work zone management to make sure that lifting activities take place in isolated areas, and also we don't have mixed circulation between pedestrians and vehicles. That's why we use spotters, and we select the proper scheduling and sequencing of activities in order to make sure that we don't have overlaps as far as it concerns the activities. Minimum personal protective equipment to be used are safety helmets, safety glasses or safety shields in case needed, and high visibility vests. Training and communication is really important in all aspects of safety. So it is really important to deliver training prior to the commencement of work, to deliver safety briefings during the execution of works, and maintain effective communication between all involved parties. As far as it concerns the vehicles, it's really important to know that they are inspected and very well maintained. They are equipped with backup alarms and mirrors in order to avoid blind spots. Speed limits are set, and that their respective, let's say, on site is being monitored. Finally, lifting and hoisting controls, we will see that in a little bit later. we follow proper rigging practices, we check the loading capacity, and we have spotters for lifting operations. The related risks to use of cranes are mainly the capacity of operators that are using this equipment, underground risks, so we want to know that the crane will be installed in areas that can withstand the load that it's transferred on the ground, that we don't have any cavities or any underground networks, just like water, electricity, or natural gas that are going to be impacted, let's say, from the lifting activities. We avoid overloading, mechanical failure, boom collapse, contact with overhead power network, shrinking loads from winds and adverse weather conditions. So for that reason, we put in place a program and we select operators that they have proper licenses, they are very experienced, medical field, medically fit for the job, and also they have the necessary training to perform the task safely. We make sure that all the equipment have all the proper licenses, the certificates, inspection protocols, and that they can perform the job safely. We develop respective lifting plans, taking into consideration ground bearing capacity, loading capacity of the crane, maximum wind speed limits that we have to stop the activities in order to perform safely, any existence of overhead network that we should avoid, and that's it. It is really important to have a clear communication plan, meaning that not only we have to make sure that we have an alignment as far as it concerns the understanding of signals, but also we avoid any language barriers, especially when we have multinational teams working at site. So cultural context will be taken into consideration and make sure that everybody understands the same thing. Define safe zone, exclusion zones are set up, especially when we have lifting activities, as we said previously. And finally, the definition of minimum PPEs, personal protective equipment, that is the safety helmet, the reflective vest, safety boots and safety goggles and glasses. Similar but not the same risk coming from the use of forklifts, having to do with operators' capacity, tip overs, overloading, pedestrian collisions, falling loads, poor visibility and blind spots, and carbon monoxide exposure, especially when the use of forklifts is being done indoors instead of outdoors. Again, we select proper operators having the necessary license, be medically fit and properly trained, pre-use operation check, and also checking that we have the necessary licenses and certificates in place, and hand visibility communication, meaning that we identify the blind spots, we put the necessary control measures in place, and we avoid this. We have separate circulation of pedestrians and forklifts, and finally we use the necessary PPEs with high importance as far as it concerns the reflective vests. CMOPs. CMOPs we call the simultaneous operations. Actually, we're talking about activities that are concurrently taking place at a specific area. An indicative example is solar panel installation on roof and interior electrical upgrades. What are the risks related to CMOPs? Interference between activities. Consider that we have a team working on a roof, performing welding activities, and we have lifting activities of flammable materials. A spark falls from the welding area over the flammable materials, and we have a fire. Things like that, we have to coordinate with caution in order to make sure that all related risks are properly identified. Communication failure, we talked about that earlier. Confined space congestion, especially when we have a lot of different crew, equipment and materials inside a confined space that can create a lot of demanding, I would say, risks. Increased fire and explosion risks from the materials that are used, equipment conflicts, especially when we are talking about cranes, forklifts, delivery trucks concentrated on the same area, exposure to hazardous substances, utility overload and malfunctions, and finally delayed emergency response when we have very crowded areas. How we respond to that? We develop comprehensive risk assessments in order to develop CMOPS coordination plan and avoid having a lot of if you will, conflict between the different working crews. We use and assign duties of CMOPS coordinators to supervise that the CMOPS coordination plan is being followed. Clear permitting system in place, especially when we're talking about high-risk activities, just like pot works or electrical works and so on and so forth. Regular safety briefings and updates during the job and job safety analysis. In this specific table, we have consolidated all the information as far as it concerns the risks, their causes, and also the mitigation plans. And the reason that we put in place all these initiatives is to proactively create a safety culture that has all these benefits that you can see here, and actually allows all the employers to execute their duty of care. Thank you very much for your time.
Questions? You can take your time.
I can take my time.
Yes.
I liked your presentation very much. I used to teach OSHA, which is the requirements for this United States. But I think you left something out when we're talking, especially in retrofits. Often you will run into mold and mold dust, if you will, and I would suggest including that. Yeah, and also you mentioned boiler rooms, and for those of you that may be more knowledgeable than me on it, aren't there required to be 2 entrances and exits for boiler rooms?
Depends on the size.
Yeah, it depends on the size. So I would suggest sometimes people get inside of boilers, and that would be one. Okay, thank you.
Fantastic. Thank you so much.
Thank you. Any other question? Kindly rate our presenter.